So we've been spending a lot of time working on completing the square. Now, one of the things we need to point out, and I've said it a few times, is that unlike square roots and factoring and graphs, which are unreliable unless technology is helping us out, completing the square is something we can use to solve any quadratic equation. Now, that doesn't mean that every one is going to be something we would make that decision for, but it can solve any quadratic equation. And it focuses on us building perfect square trinomials. That's the idea behind completing the square. We take a situation where there wasn't one originally, perfect square trinomials fitting this format, and we build it from what we have and adding any extra pieces that we need to create that situation. Because situations where we have perfect square trinomials, we can factor to be one term squared, one binomial term squared. Now, we specifically want to have one thing be true. If that's what we're working with, though, we need a to be equal to 1. So let's look at how this actually works. 3x squared plus 18x minus 120. Now, here's our process. The very first thing that we need to think about is that we want a to be 1, and we achieve this by dividing by whatever that value might be if it's necessary. In this case, a is 3, so we'll divide everything here by 3, and we'll rewrite the equation to be whatever we end up at. X squared plus 6x minus 40. Now, x squared plus 6x, those are the building blocks that we start with. The minus 40, at this point, it's just in the way. It doesn't create a perfect square trinomial, so we get rid of it. We'll move it to the other side of the equation. It's not doing us any good like it is. We're going to represent what we need by adding in some pieces that we know are necessary. Now, where do we come up with what we need to add? The mechanical thought process would be that we look at that b value. It's 6. We take half of that 6, so 3, square it. Now we've got 9, and we add it to both sides of the equation. Both sides because we need to maintain balance. Now, when we do that on the left side, we've created that perfect square trinomial, x squared plus 6x plus 9. Factor that. Next step. X squared plus 6x plus 9 can be factored to be x plus 3, the quantity, squared. Now that's equal to 49 because the 40 that we ditched originally and the extra 9 that we added, that's all part of the process. Now, this setup should look familiar. We solved using square roots when this is what we saw. I will take a square root of both sides, and in doing so, I'll free up x to be isolated. When I take a square root of both sides, I arrive at x plus 3 is equal to plus or minus 7, which is really two different equations. X plus 3 is 7, x plus 3 is negative 7, and when we finish those off, it turns out that x equals 4 or x equals negative 10. There's our two solutions. That's the entire process, start to finish, for completing the square. Well, let's run through one more. If I'm going to complete the square, I start with x squared plus 16x minus 30. Now, my process said the very first thing I need to think about is a 1? And I get there by dividing if I have to. In this case, a is already 1. It's 1x squared. So I don't need to worry about that step for this problem. If we remember correctly from the last one, our next task was to get rid of that constant. That negative 30 is what's standing in the way of that being a perfect square trinomial. So I'll add 30 to both sides. Here's where I build the perfect square trinomial. I need to turn x squared plus 16x into some trinomial that can be factored as the product of the same term with itself. So I'll take half of b. b is 16. Half of b is 8. I'll square that, and I'll add it to both sides. This creates a perfect square trinomial on the left side, and all the leftovers are just on the right. Now, step 4, let's factor that. X squared plus 16x plus 64. We spent all that time building it. Let's make sure that it represents what we wanted. I get x plus 8 squared. Here's our familiar process. We're going to solve with a square root. Take the square root of both sides. X plus 8 is equal to plus or minus the square root of 94. Now, the square root of 94 is not a perfect square. It is not a very nice number. It's somewhere in the neighborhood of 9.7, so that's what we'll use for our approximation. So plus or minus 9.7. Writing two equations, taking that last step to solve, we have x equals negative 17.7 or x equals 1.7. That's our completing the square process. It's very useful in the grander scheme of let's solve quadratic equations.